This is Phil with Mech 140, and for my first robot, I built a MazeBot. The first few slides you're going to see are the components I used to put together the MazeBot. You're going to have the Vex steel and components, gears, wheels, the Arduino, sensors, push buttons, and motors. Once the robot was completely built, we were tasked with traversing the maze. As you can see, it needs to go into the maze, take a left, take a right, go over the bridge, take a right at the end, and exit the maze. Part of the lessons learned here was that the larger gears I used between the wheels were getting stuck at the top of the bridge. I had to swap those out for smaller gears and then use larger gears where the wheels were. The video you're seeing is actually cut together from an overhead view and a view with the camera on the robot. If you wait till after the code at the end of this video, you'll see the full uncut version of both the overhead view and the front view. As you can see, this is the Vex LCD that I actually have mounted to the robot. Every time that something happens, the button is pressed, it does a new command like turn left, move forward, or stop. That's displayed on this Vex LCD and is very useful for troubleshooting. The first two lines here are the libraries were included, Servo H and Vex LCD. These are pre-written code libraries that are available, so we don't have to write the code ourselves. Next, we have all of our variables that we have to declare. We have to set up the right and left motors, the LCD, the push button, and then we have to set the variables push button state to 1 and AwesomeBot 0, which is our counter. Next, we have the void setup. In here, this is where we declare which motor is attached to which output, 10 and 11. We also have to initialize the LCD, clear it, and also set the push button as an input. Earlier up above, we actually set up the push button to input 2. Next is the void loop. This is the main program, and this is what will run over and over again until the program is complete. First, we're going to declare push button state. This is where we're going to do digital read the push button from input 2, and this is where we'll store the value in there. Next, we're going to set our robot to move forward. We have to set the speeds or a value for the speeds for each motor. Because they're both facing opposite directions, they have to be opposite numbers from 90. Whenever the program's running and it's moving forward, it'll always display moving forward. The next thing I decided to do was to use a switch variable, switch in case, rather than while loops. I do have a while loop, but I wanted to use these switch in case functions to actually give me something new to work with, since I've not previously worked with them. The way this works is there's a variable that's set up, AwesomeBot. Every time a push button is pressed, it adds 1 to that, and so then it'll run a different case. So the first time it's pressed, it runs case 1, second time case 2, so forth and forward on to case 4. Case 4 is actually where the program is going to end. Next, you'll see here where it says if the push button state is low, stop both motors and add 1 to the counter. The last part of the code are cases 1 through 3. This is where it'll stop, back up, stop, and turn. Depending on the case, it'll turn left or right. When it gets to the third one, it'll add 1 more to the timer. It'll come back up to the top and run the case 4, where it'll move forward for so long. It'll stop and it'll display program complete, and then the program will end.